My name is Kyungsoo Yoo. I'm an associate professor in our department. And first, I teach source formation of the graduate course. I'm teaching it this fall. And for the first time, I'm also teaching the RAS 50/50 with Tracy Twine. So we plan to kind of rotate those two courses each other year. And also, my student is Adrian Wackett, who is currently in London, but until yesterday he was in Sweden and Finland. And my heart was a bit aching because, I was kind of wondering whether I should best teach her, and she is graduating, she's over there, she just defended. And I also supervise Dr. Sia Wang, who is working as a postdoc with me. In general, I'm interested in the things that are in motion. So I'm interested in kind of interactions of the minerals and organic matter and organisms in the soil, or how they kind of interact with each other as they move in the soil and across the landscape, and how those interactions during the movement are affected by human intervention. So I'm giving you two examples of my research, and the first one, this example, is research that was funded by National Science Foundation, and the work was done in northern Sierra Nevada, where we have impact of the rapidly incising MFFR, which is the Middle Feather River, as the river kind of cutting into this granitic basalt. It has created significant relief over the last tens of million years. But the river's kind of incision signal has been transferred to those unlanded parts of the channels, as channels kind of cutting into this landscape. It has created a series of the hill slopes with different stiffness and different rates of erosion. So using those in a natural background, I and my students and my postdoc have been interested in kind of understanding how those erosion can contribute to geochemically shape the landscape and also the interactions between the minerals and organic matter. So I also have kind of similar projects going on in Australia as well. And the best teacher who just defended, and she also looked at the cow-mineral interactions and actively eroding landscapes in Pennsylvania. So some of you may know that I'm interested in oceans. Oceans, they are big agents of moving soils. As they move the soils, they affect the chemistry of the soils, but also they affect the interactions between minerals and organic matter. I did that work in Minnesota, and because Minnesota was glaciated, so those the forest soils have evolved over the last 10,000 years without native earthworms. But then the situation has changed as European immigrants moved with earthworms, and the fishing also bring the earthworms, etc. So that kind of provides me a very unique opportunity to understand how earthworms kind of change the ecosystems to begin with. But during my sabbatical year, which I spent part of the time in Sweden, I began to realize that the concept can be also applied to some Swedish Arctic landscapes, because that Sweden and Finland and Norway and much part of the Arctic have been also glaciated, but then they have been just populated with humans for a longer time. So we began to think that that could give us a really wonderful opportunity to think about how humans, by spreading out the earthworms in this cold environment, and have changed their ecosystem processes. And right now, so last summer, and my student Adrian Wackett, myself, and my collaborator Jonathan Kraninger in Sweden spent a long field trip in Arctic Sweden and laying the foundation for that hypothesis. So my general interest is in soil erosion and bioturbation, and also how humans affect those, the effect of erosion and bioturbation on soils. And my short-term goal is publishing and securing some grants for a global warming project. But I also have a kind of long-lasting hope to write a textbook on soils. And my passion is kind of an intersection between soils and earth system science and the human society. Thank you.